In the previous video, we talked about how to do binary search over an array in a recursive manner. Okay, so our idea was that we are going to search for a value v from left index up to the right index, and we checked if value of left is greater than right. If that's the case, it means that we have exhausted our search and the value is not present. Otherwise, we found out the middle element, and if we find the value at middle element, we report the success, we report that index. Otherwise, if the value is less than the middle element, we search to the left of middle. Otherwise, we search to the right of middle. That was the idea of binary search. Okay, but now let's think if we can implement the same algorithm in an iterative manner. So we are not going to change the algorithm. We are just going to change the way we implement it. So we still have the search algorithm which sends us the value v, and it sends us the left index and the right index. So within an array we have to search between these indices. Okay, so that's what is the expectation from this algorithm. Okay, so we will do the same thing. So first we'll check if our left is greater than right, and if that's the case, we should return -1, indicating that the value is absent. And if that is not the case, what should we do? We should do something iteratively, right? Because we are going to start with the whole array, then we are going to partition, and then we are going to compare at the middle and then decide to search in the left or in the right. But once we choose the partition, we are again going to find the middle, and so on. So this is something that is going to happen multiple times. So what we need is a looping construct. Okay, and for this looping construct, something should be true. And what is it? The requirement is that we have to search only if the left is less than the right. Okay, that's the requirement that we have. Okay, so now let's keep that thing. While the left is less than or equal to right, okay, we should do something. What is it that we should do? Let's think about it. First we have to compute the middle. So we'll compute middle equal to left plus right divided by 2. So we got the index. Then we should compare our value. So if v is equal to get element at middle. Okay, and if it is same, we should return the middle. If that's not the case, we should ask question if our v is less than get element. Okay, get element at the index middle. Okay, if it is less, we should search to the left. So what I would do is that I would only change my right pointer. Left would still remain the same. So I would say that my right should be equal to now middle -1. Okay, so this is my if block. So let me write it in a better way. Okay, so this is first if we find, I'm going to return, and now I have if. I will do something inside it, which is return. I'll just make right equal to middle -1. Otherwise, I know that the value that I'm searching for is greater than the middle element. In that case, I would change left. I would say that my left is equal to middle plus 1. Okay, fine. And then what should I do? I should go back and do my search. So I will close this loop. Okay, so that's what our algorithm should look like. But if you notice, this is a bit redundant. Okay, so we can actually close this block because we are already checking if left is less than or equal to right. However, if this is false, at the end we should have return -1. Okay, and that should complete our binary search in an iterative manner. And let's compare this against our recursive algorithm, because we are not changing the algorithm, we are just changing the implementation. So in the recursive implementation we have 3 cases: equal to, less than, and greater than. Here also we have 3 cases: equal to, less than, and greater than. Okay, in recursive algorithm, if it was equal to, we returned the index. Here if it is equal, we are returning the index. In the recursive method, if the value that we are searching for is less than the middle, we search in the left and middle -1. If the value that we are searching for is less than the middle, we are searching in the left and the middle -1, because we are not changing the value of left here. And in the recursive method, if the value that we are searching for is greater than middle, then we are searching in the middle +1 to right. Here we are doing the same. We are altering the value of left, keeping the value of right common, the unchanged. Okay, so algorithm wise it is the same thing. Okay, there is no difference in the algorithm. It's just that we have a different way of implementing it. So with this we won't have many recursive calls, so we will stay within one function call and we'll get the required output. Okay, that's our binary search iterative. It has the same time complexity as our recursive implementation. So you can check how this function works, or if it doesn't work for the various cases that we considered for our recursive method, right? So try this input array which is sorted, try out various inputs, inputs where the value is present, inputs where value is absent. Okay, try to run over this pseudocode. If it works, fine, and if it doesn't work, if you can find out cases where it is having problem, let me know during the interaction session on Monday. Okay, and then we can discuss if this pseudocode requires any correction.